Good morning, Dr. Chan, and good morning, everyone. My name is Han Xiaoming. So today our group will going to present our assignment, which is about wheelchair. So this report is going to investigate a real-life example of static and mechanics of materials. We will focus on the wheelchair. The objective is to identify a structures or motion-related problem associated with the wheelchair and propose a potential improvements. So here we will focus on the three main points here. The first one is the force analysis, the second one is the moment calculations, and the last one is the force distributions. So for the force analysis, the total force acting on the wheelchair system is calculated using the weight of the wheelchair, which is a 10 kilogram, and the person, which is 60 kilogram. So to ensuring the equilibrium, so we are using a formula of the total Fy is equal to 0, and with the force exerted by the ground. So the second one is the moment calculations. So we're using the moment around the front of the castle, which is the total moment castle is equal to 0. We use this formula to find the force exerted by the ground on the wheel, based on the distance from the laying caster and the laying wheel. So the last one, the force distributions. We're using the calculated force weld to the force exerted by the ground on the force caster is determined, ensuring the system will remain stationary and in equilibrium.
I'll do a brief introduction regarding to the report. First is static overview. Static is a study of forces on object at rest which ensure the object is in equilibrium and no acceleration. Mechanics is the study of motion and deformation under forces essential for structural design. The importance of statics and mechanics in wheelchair design is to ensure the reliability of wheelchair under different loads. Most important factor to be considered is the force distribution, friction, material strength, and deformation. Friction is the force opposed to motion between the surfaces. There are two types of friction, static friction and kinetic friction. Static friction is to prevent the motion until max threshold, while kinetic friction, which governs motion after exceeding static friction. Next, we'll talk about stress and strain. Stress is force per unit area, while strain is the deformation per unit length. The stress-strain diagram helps to analyze material properties. Lastly, the design consideration. We have analyzed the bending, torsion and shear stresses to prevent failure. The selected materials is also with suitable yield, strength, and modulus of elasticity.
The objective of this project is to utilize free body diagram to perform equilibrium-based analysis. Second is, we will solve the problems involving axial, bending, and torsional loads on a body. Third is, we will conduct moment and inertia-based analysis for solving problems. CLO4 is, assess stress and deformation in biomedical device. The last is, work collaborative as a team to analyze real-life cases of static objects.
Okay, so let's focus on the methodology 4.1, which is the forces on the wheelchair. So through the figure 4.1, you can notice that as a student of 60 kilograms sitting on a 10 kilogram wheelchair. So this is the force that I draw here. So the materials and the apparatus that we use is a 10 kilogram wheelchair, and also the measuring tape and also the smartphone. So we're using the equations total force on the y is equal to 0. So the value of the summations of the force exerted on the casters and wheels by the ground, force caster and force on the wheel are obtained. So the moment around the front caster is calculated using the formula total moment of the caster is equal to 0 after determining the sign convention to find out the value of the force exerted on the wheel by the ground.
To calculate the internal moment and forces in a wheelchair axle, first we measure the wheelchair axle length and wheelchair radius. Calculate the student's weight with the formula W equals to mg. Draw a free body diagram with forces and moment just like shows in the picture, and use the equilibrium equation which summation of fx equal to 0, summation of fy equals to 0 to find the vertical and horizontal forces. Lastly, Calculate the moment using summation of m equals to 0.
Shear stresses on bolts. First, bolt circumference measurement to determine diameter. Second, weight calculation with the formula W equal to M times G. Third, use free body diagram to showing forces acting on the bolt, sign conventions, and coordinate system use. Next, calculation of the area of the bolt being shared with the formula A equal to PD square divide 4. Next, determination of shear stress on the bolt with formula tau equal to F% divided by A. And lastly, comparison of calculated shear stress with bolts shear strength.
Now I would like to talk about the result that we get. With the information given, we will calculate the force of the person exerted on the wheelchair, F equals to mg. Next, we'll calculate the diameter, C equals to 2r, and we get the diameter. Next, we'll calculate the shear strength of steel. Now, I would like to talk about the forces on a wheelchair. By referring to the free body diagram, we will assume that the total Fy equals to 0, and we will get the equation of F wheel equal to F person L caster over 2 L wheel plus L caster. And we will found F wheel and also found the F caster. Next, we'll calculate the internal moment and forces in a wheelchair axle. Assume that the total Fx equal to 0, then we will get the F axle horizontal. Assume that the total Fy equals to 0, then we will get the F axle vertical. F axle equals to square root of F axle horizontal square plus F axle vertical square. Then we will get F axle. Assume the total moment equal to 0, then we will get the moment of axle. I will talk about the shear stress on bolts. The formula of the area of metal being sheared is A equals to pi d squared over 4. Shear stress equals to F% over area. Then we'll calculate the shear strength. Since the shear strength of the bolt is much larger than the shear stress, the bolt is plenty strong enough for the S-brace.
In the first part of discussion, I'll talk about the forces that may cause failure. To prioritize user safety, specific guidelines dictate the required mechanical strength of wheelchair components, including seating. However, exceeding a wheelchair's weight capacity can lead to reduced stability, impaired maneuverability, or even complete malfunction. I'll separate the factors into three parts: overloading risk, shear stress impact, and corrosion effects. In overloading risk, first we'll talk about the mechanical failure, which reduce stability, impair maneuverability, or structural damage. Second, we'll talk about accelerated wear, which increases brake wear, degrades seating, and reduce user comforts. Lastly, the user safety, which is the difficulty in operating wheelchair, discomfort, and increased risk of falls or injuries due to improper weight distribution. Next is the shear stress impact. First, axle damage. It occurs due to twisting or bending of axles when improperly lifted by wheels. Besides, bearing issue occurs when damage to bearings, leading to noise, looseness, and reduced maneuverability. Frame weakening, stress and joints causing bending or breaking, and lastly is the cracking or breaking of upholstery, armrest, and attachment, reducing comfort and usability. The last part is the corrosion effects. First, material degradation, which is a damage to protective oxide layers in aluminum and stainless steel. Next, lifespan reduction. Rust build up causing stiffness, instability, and appearance issue. Last, environmental factors. Corrosion worsened by exposure to chemical, moisture, saline, grease, or heat over time.
Now let's discuss the solutions to address wheelchair overloading and improve user safety and comfort. Firstly, it's crucial for users to follow the manufacturer's guidelines. This includes adhering to the recommended weight limits and selecting the appropriate wheelchair based on their specific needs. Next, ensuring a proper fit is essential. Users should choose the right type of wheelchair, whether it's standard, lightweight, or recline. Key measurements such as seat width, back height, and seat depth should be considered to prevent discomfort and posture issues. Consulting healthcare professionals is also important. They can provide advice on additional support, such as extra cushioning or back support, tailored to the user's specific requirements. For designers, conducting a thorough structural analysis is critical. This involves assessing the loads and forces acting on the wheelchair to calculate shear stress, ensuring the design can withstand the expected stresses. When it comes to materials, aluminum is preferred due to its lower shear stress value, making it a suitable choice for constructing wheelchair forms. To manage shear stress effectively, using cushions, back support, and footrest help distribute pressure more evenly, reducing the risk of stress-related damage. Lastly, for corrosion prevention, applying a rust-inhibiting primer and paint can protect the wheelchair from exposure to elements like oxygen, saline, and grease, prolonging its lifespan. This solution collectively ensure that wheelchairs are safe, comfortable, and durable for users.
Okay, so now let's move on to the 6.3, which is the assumptions. So while conducting an experiment, several assumptions were made to ensure its success and simplify the calculations. So the first one is a new and undamaged equipment. The wheelchair is assumed to be the perfect condition to prevent deviations in force measurements caused by the wear or damage. So the second one is the equilibrium and stability. So the all forces and moments when acting on the wheelchair are balanced, ensuring it remains stationary and unaffected by the external forces. So the last one is an uniform weight distribution. So the person's weight is evenly distributed across the seat, avoiding inaccuracies from uneven forces application.
In this project, we apply statics and mechanics principle to analyze a wheelchair's design and functionality. For LO1, we created free body diagrams and conducted an equilibrium analysis, confirming that the forces on the wheels and caterers balance and uses weight, keeping the wheelchair stationary. For LO2, we evaluate torsional loads and shear stress on the boats, finding their shear strength as seats apply loads, while proposing mitigation strategies for potential shear failure. For LO3, we assess the effect of overloading on structural stability and user comfort, identifying risks and suggesting improvements to enhance safety and performance. Continued research in wheelchair design using this principle is crucial for improving functionality, safety, and user comfort.
So that's all from our group. Thank you.